All right, today we're cracking the code on a chapter that is an absolute goldmine for marks in your board exams, chemical reactions and equations. We're not just going to revise it, we're going to hack it by figuring out what the examiners really look for year after year. You know that feeling, right? You're looking at this giant stack of old exam papers and you just feel totally lost. Like, where do I even start? Well, you're not alone. It's a super common feeling. But here's the good news. There's a pattern hidden in all that chaos. And that's exactly what we're going to do here. We are going to pull back the curtain on those recurring themes, the questions they ask over and over, and the core concepts that are practically guaranteed to be on your paper. This is all about studying smarter, not just harder. Okay, let's dive right in. First things first, we got to look at the big picture. How does the board actually structure the questions for this chapter? Seriously, understanding the format is step one to absolutely mastering the content. Now, what's really interesting is the mix of questions they use. They're not just going to test you in one way. They come at you from all angles. You've got your fast, quick-fire MCQs, then you have those tricky assertion-reason questions, and of course the more in-depth 2- and 3-mark questions where you really have to show you know your stuff. So here's the secret sauce. Some skills are just universal. If you can get really, really good at balancing equations, you're pretty much set for any question type they throw at you. And listen up, this is a big one. Pay super close attention to the lab activities in your textbook. The examiners love, and I mean love, to see if you can connect the theory to what you'd actually see in the lab. Okay, let's jump into our first high-yield topic. If there is one thing you can pretty much bet on seeing on your exam paper, it's a question about decomposition reactions. This is a topic that the people who write the exams just keep coming back to. So, just a quick refresher. Decomposition is all about one thing breaking down into smaller pieces. Simple, right? The key thing to remember is that it needs a push. It needs energy, like heat, light, or electricity. And this is exactly why examiners are so obsessed with it. A single question can test if you know the reaction, if you can balance it, and if you understand the energy involved. It's like a 3-for-1 deal for them. Want to see what I mean? Here's a question straight from the 2023 paper. It's about heating lead nitrate. The absolute key to getting this right is knowing the observation. You're going to see brown fumes of nitrogen dioxide. That's the classic telltale sign of this specific reaction. And this is where it gets really interesting. Take a look at this question from 2022. Look familiar? It's almost the exact same question as the one from 2023. It's testing the very same concept, the very same observation. This is what we mean by a pattern. When you spot this kind of repetition, you know you've struck gold. So, what's the game plan? Easy. You need to focus on these 4 specific examples. You have to know the reactions for heating ferrous sulfate and lead nitrate. You need to know what happens to silver chloride in the sun, and you absolutely must know about the electrolysis of water, especially that 2-to-1 ratio of gases. Master these 4, and you're going to be in fantastic shape for this section. All right, let's move on to another topic that is just a surefire way to bank some serious marks. Balancing equations, and of course understanding redox reactions. You see, the board doesn't just want you to be a robot who can mechanically balance equations. They want to know if you get the why. What's the fundamental core reason we have to balance equations in the first place? And here it is, the big why. The law of conservation of mass. This is basically the golden rule of all of chemistry. Atoms don't just appear or disappear in a reaction, they just get rearranged. So balancing an equation, that's just our way of doing the chemical bookkeeping to make sure we're following this super important law. Now, let's talk redox. I know, it can seem complicated, but it's really all about tracking what's happening with oxygen, hydrogen, or electrons. Just think of this little chart as your ultimate redox cheat sheet. If a substance gains oxygen, boom, it's oxidized. If it loses oxygen, it's reduced. It's that straightforward. If you can master this simple idea, you'll be able to crack any redox question they throw at you. And here's a perfect example of how they'll test you on this. This question from the 2024 paper gives you a reaction and asks you to figure out the oxidizing and reducing agents. If we use those rules we just talked about, you can see that H2S loses its hydrogen, so it gets oxidized, which makes it the reducing agent. See? Not so scary after all, right? Okay, so we've cracked the code. We've identified the high-yield topics. So what's next? Well, let's turn all this knowledge into a practical, must-practice checklist to really lock in your understanding.
This right here is your high-impact practice list. Number 1, the classic ferrous sulfate decomposition. 2, the famous yellow precipitate reaction, a perfect example of double displacement. 3, the iron nail and copper sulfate solution, a classic displacement reaction. And 4, the oxidation of copper powder. Seriously, if you can confidently explain the what, the why, and the how for each of these 4 scenarios, you will be unstoppable in this chapter.
Okay, let's tie this all together. We have all the pieces of the puzzle. Now, how do we build a simple, powerful revision strategy that will basically guarantee you a top score? Here it is in just 3 simple steps. First, master those specific repeated reactions we've been talking about. Don't just know them, own them. Second, practice balancing equations until it's just muscle memory. And third, memorize the key observations. The brown fumes, the yellow precipitate, the solution that changes color. Those are the little details that get you the full marks.
So, to wrap it all up, the board exam isn't designed to trick you. It's a game, and it has clear rules and patterns. By focusing on these high-yield topics, connecting them back to what you'd actually see in the lab, and practicing strategically, you can walk into that exam hall with a clear plan for success. We've cracked the code. We've given you the blueprint. The path to acing this chapter is right in front of you. By studying smarter, you can turn this chapter from something you worry about into a source of guaranteed marks. You've